do we have a portfolio of work? I think so. We'll have a portfolio of work or some sheets that they are going to do at the end of the semester. Or drawing the loading calculation. It is not the lateral systems. What is the weightage of plates and portfolio? So this I will have some comments which I think probably you will agree with me, and we'll go by that as a criteria. It's how many questions per student, that and all. I think you have generally have an idea. We already done that. It's 2 or 3 questions or whatever. And how many questions we need in the question bank? I think that's again 100 or 120 is what we'll try to target the number of questions. And you will try to frame those questions in such a way that I think as faculty you should be able to teach that thing so that the student should be able to get that answer out of it. I mean, that's the way we're looking at it. And few of you are attending this seminars for the first time. Is we want you to come up with questions that would become part of the question bank. And the Viva OC, you will be of course one of the Viva OC members. The external Viva OC members will be appraised of the questions that the students are prepared for. So that's the way we are looking at. So it is very important for two important things. One is to come up with questions, and second thing is when we put in the question, whether you could be able to teach that question to the student, because we are looking at the average student. Again, we're not talking about exceptional students. We're not talking about the others also. We're talking about an average. Yes, we are talking about an average student who should be able to answer this question. That's the whole criteria. Set up as a minimum criteria, and the other one is what we call as the maximum criteria. The minimum criteria, let's say that students should know about basic loading, meaning dead loads, live loads, and wind load. Wind load is the only thing that is going to be, we are going to concentrate in this semester. We are not going to concentrate seismic. Seismic comes in the next semester. The only thing that's going to be, we are going to teach the students is what is the dead load, wind load, live load, which we already taught in 2 semesters. So it is a repeat. Again, those are all very important topics. What is a live load, what is a dead load, and what is the design codes we have to use for live load and dead load. So that we are going to repeat. And then what we hear, the new introduction would be wind loads. Basic calculations of how to calculate a wind load. So that one criteria. And if the student gets an introduction to all these systems, I think probably, and the portfolio is complete, probably I think he gets a 50% marks. Let's put that as a minimum criteria. So objective of this course, if you really look at it for faculty and any of the thing is, if at the end of this course, if a student knows generally about loading, generally knows about some history of these long span structures, how it was done historically, and what are the current ways of doing these long span structures, and if they are able to do at least 4 or 5 systems of thing, if they ask them and give them a sketch, not the span that is there, they have drawn. If you tell them, okay, this is a span, can you draw a structural system? They should be able to do that. This is what we call it as 50%. If a student is able to comprehend so much, we should tell them, okay, you're passed or you get the 50% grade. Next 50%, again I leave it to individually of you, because it all depends on the students, how they want to get involved. Again, I'm telling you, this is it's too complex a topic. Each topic, introduction to, let's say, design of a total frame. I'm telling you, in a master's level ME course, I can teach it for 16 weeks, just this course. Design from total to design to detailing, designing to everything. It will take me 16 weeks to teach the whole thing. Just this, design of arch and walls. Probably, just the topic, just the introduction from history, how it was started, it will take a 16 weeks. So what I leave it to rest of the faculty, and the thing is, depending on the students' keenness to do this, we will leave the student to how much they want to absorb or anything. But this is a fantastic opportunity for students to learn about all this. These are the things probably they would be using it, or in fact if they get into an architectural practice, one of the first things probably is in the interviews they might be asking you some of the things. Do you know about this at least? Do you know about this? Forget about whether you do it or something. Do you know about this? If they say that if they know about it, that itself is, we have solved the problem. So what we set as a basic criteria as 50% is, as long as they know some loading, some history of long span structures, and they know how to design, design in the sense sketch. That's the whole idea. It's not even design, sketching, proportioning and sketching of a long span structure. See, we probably give them a 75 meter by 30 to 300 meter span, but eventually if you give an 100 meter span, ask them to sketch or do something, they should be able to at least get an idea. That's the whole idea. If they do that, they get 50% leave it to individually of you faculty to look into how that could be done. So the first topic is again, introduction to long span structures. As I told you, this itself can be a topic by itself. Historically, if you look at it, even our structure is there. People we ignore our structure. Golgumbas, that's again one of the, it is still the second largest masonry long span structure in the world after Hagia Sophia. That's Hagia Sophia. If you look at the clear span, the dome span is less, but the clear span of Hagia Sophia is still the largest, which is 76 meter span, 250. So this history again, what I suggest is you could talk to the architecture faculty and get more inputs. And this introduction, as we are talking about, is again, it can be introduced in a wide way. One of the things is Pantheon is this, this is a National Geographic study where some studies were done on just on domes. This would be just a research topic, PhD research topic for an architectural student, but how domes are evolved historically. So the first topic, first introduction would be is the first week of it, the right way to introduce this topic is historically how the long spans were done. And most of the examples happens to be masonry and of course wooden domes when it comes to later part of Renaissance and other things. But of course, the emphasis on our structure and things like that. And again, just to give you just an idea, this Roman Pantheon, this 143 meter span, was the longest span for 17 centuries. Imagine the credit that engineers or the set of engineers would get. For 17 centuries, that was supposed to be the largest span. Now it is again giving them the importance about the importance of the wide span. How an engineer or a group of engineers were able to do certain things, which was the benchmark for 17 centuries, not 17 years or 17 centuries. So this history again, I leave it to you as in somebody in Bijapur or some historic cities. You could probably take them to the site and explain them. It's again two studio and two thing. It can be explained taking them to sites, or it could be explained them as history. I would highly recommend you to take the help of architecture faculty, especially history, and there's a lot of relevance to it. And this is how we try to bring in relevance of architecture, relevance of structure into the design. That's the okay. Each of those presentations have my sub-presentation that we'll be going through. So second week of the thing, first week is we're going to give an introduction. Okay, we didn't discuss about the questions. See, some of the questions that could be asked is, name few historical domes, or which was the largest span, Pantheon example, how long it was and what was the span, and these examples, all your St. Peter's to Golgumbas to Taj Mahal to, what are the approximate spans? We can talk about, we can bring about 5 questions here, including the Indian examples. We can ask them questions like, start noting down, so that what are the historically, what are the spans and how it got then, and you can also bring up a few more questions. This is not the end of it. Probably we'll try to reiterate, and when the whole question bank is done, that's all it is. And as a student, probably they ask them to do a contemporary structure, or even they could even do some modern structure also, because it's an introduction. So we should give some openness to the students. Not necessarily an old structure, they could also do the new structure, which anyway we'll be introducing. So in the second week, we are going to introduce them to a problem. We introduce them to a problem. Again, this is how we have done our, if you notice, this is how we have done it in our RCC and STEAM. The way we introduce them is to design, not necessarily look at the systems in isolation. You always look at into the context. This is the one thing that's different from the old syllabus to the new syllabus. The old syllabus, if you notice, was always a part to whole approach. Meaning you went on to design look at the board, look at the individual details, columns, beams, and things like that, and eventually you should come to the building. But the approach here is you start from the building and get to the detail. And again, as we are talking about as architectural students, you only get to the detail whatever is relevant. Again, this problem that we have given is only what we call as indicative. We should each semester, I mean next year you should be changing the problem. Meaning or else then they will start doing your GP and the same set of drawing starts to come up. You should be very careful about students not repeating the work. So this is only an indicative. I mean, first anyway, this is the first course that we are starting. We start with the problem which is right now is a 75 meter span. 75 meter span, about 250, about close to 250 feet span and a 300 meter span. And we tell, we go through I think 6 or 7 structural systems to cover this. That's the whole way of looking at it. So we introduce the problem and we also introduce them to not the design again as we are talking about. We are not talking about design in terms of fully detailing of structural design. We are talking about proportion. The emphasis here is geometry. How do we geometrically design a structural system for the span?
And selecting the material.
Selecting the material and system. Structural system, material, and this is what our focus is. Of course, even loading and other things, there is some focus, but our primary focus has been to identify a structural system.
Proportioning using IS 456.
Yes. Yeah, total weight calculation. Yeah, I'll tell you, we'll go through about how we do it. This is for, we are just introducing in the problem. We'll go through individually. And once you introduce this, I think this is a presentation I got it through the internet actually, which is a very good presentation. In fact, I know happened to professor who knew it. How do I get to the full screen? How do I go to the? Okay. So in this, when you introduce the problem also, we are going to generally introduce them to the available certain systems that is there. This is one of the presentations. Again, I always recommend the presentation, the content that I am giving is only for your reference only. I mean, I recommend each of your faculty to start developing your own way of teaching this course. So here what we are telling is, in the first class we introduce them historic part of it, and the second class we introduce them the problem, and we also introduce them what are the, I mean in the broader way, what are the possibilities to do that system. What are the ways of looking at this 75 meters by 300 meter span, what are the ways of doing it. The things that we'll be looking at is what are the loads. Introduced in the first class, how it has been used in many other buildings, in the examples wise, and this gives them what you call as the bird's eye view about what is coming in the rest of the semester. The structural systems and things like that. Then we go through, first pattern is the loads, then we go through the individual systems, like a long span truss, what are the basics for design of long span truss, and how do you proportion. For this, I think we are fortunate enough because the professor or the reference that we have given has got a chart, essentially has got a chart which essentially gives you what you call as the span to depth ratio. Span to depth ratio is one thing, and the individual member to thickness ratio. So two things are given, which is what is going to, this is whole semester will be based on that, is based on that chart, which is, the chart is essentially has got what you call as the span to depth ratio. For a span, what is the depth it should be, and individual members, member length to thickness ratio. I was also mentioning, she is giving you the details about it. So this is the relevance of using the history faculty to look at this whole thing, not just as a structural span issue, but also how it was historically, how they tackled the wider span.
So we may teach history also as a structural field.
Yeah, exactly.
Especially the Roman architecture and end of Byzantine. We teach it as how material and long span structures were.
Yeah, I agree.
So
I agree. See, eventually the combination would have been ideal, but what happens is right now is we have to focus on one thing and take the inputs from the other faculty and present this in a better question. That's exactly the why.
The syllabus covers domes, arches.
Yes, it covers. Yes. In fact, they go and design the dome. They go ahead and design the dome for that span. For that 75 meter span, they go ahead and design the, I think we have to be on this. I think we have to turn on the, this is the second week where we are introducing the topic and we are giving them an introduction of a thing. And this presentation that again I told you I got it off from the web and it's got a very relevant topic thing. So loadings acting on a structural system will be get live and window. That's what we'll be considering in our later part of the semester. And again, what is the definition? See, this is one more thing. This is again one of the questions that we should be asking for the students is how long is a long span for a building? One of the one is again one of the definitions. There is nothing called as an absolute definition here. Structures which spans more than 20 meters can be regarded as long span structures. For this, the span is usually unable to be achieved by ordinary RC structure. I think this is the definition, and why it is becoming important is until this point in India, we were only keeping it to the 20 meter span or even less than. So now the reason why we need this horizontal span structure, why there is a need for the horizontal span structure, that is again the question. And one of the other questions that we could ask is, where are the relevant places where we need the long span? It's an aerodrome, and your stadiums, your long bridges, this is again a question, when do you need a long span structure? That's again a question. And what is a long span structure? And what are the ways of doing this long span structure? Again, what are the materials that you can use for this long span structure? Again, we don't use timber and lumber timber here, but still, it's there. It's typically we go through only reinforced concrete, there is only shell part, then the steel and fabric. So structural system, again we will be going through it for long span. So see here again what I told you is we are introducing the topic. We are telling them we are going to span this whatever, by these are the available systems that is there. Again, this is a technical definition, but you should also, people should know about technical definition about how do we do this, what you call as the long span structures. They are classified into 4 types. One is called the form active systems. The span is achieved by just the form itself, like a fabric structure or thing. Vector active system is basically trusses and things like that. It's vector, it's a forces. Section active systems and surface active systems. I mean, surface again is a thing. If you get into the detail of it, form active systems is cable, tent, pneumatic structures, R structures, and things like that. So this is these examples of form active structures are this. See, this is again, as I told you, it's the second week of the topic. Second week, we are introducing them. You will eventually we are going to do 5 or 6 systems in your whole semester, and we are just introducing what are the possible ways. And I think we should be also open. If there are students who thinks that they can do something beyond this also, I think we should be open. But again, we will not restrict them, but we will typically restrict to whatever is in our syllabus and things like that. So again, as I told you, second week we are introducing. We are giving them an idea about how do we cover the 75 meter by 50 meter thing. There are a lot of options. This is again, first is the form active system that we are talking about. This is arches, again form active. Next is vector active system, which is actually trusses, curved trusses and space trusses. So it is again, what are the ways of doing that 75 meter by 50 meter. We are going to go through 5 systems, but this is the second class where you are introducing them to all possible ways of doing it in contemporary terms. See, that's again, first is historic terms, second is the contemporary terms. Here the questions could be like, what is let's see, I don't know whether we should ask those form active as a technical question, but we should be just going about it. What are the means of structural system available classification in terms of currently in India problem. Just quickly go over this. Again, trusses, there are different ways of doing trusses. Again, even the portal frames, there are ways of doing that portal frame. Even just the regular flat thing also, there are ways of doing it. So, we are going to go in detail about each of them. And again, when you get to the folded plates, these are all what called as the again, when you do the historic thing, we can talk about how the Gothics really got onto the force transfer and how they were able to build those structures. So Munich Stadium. I just want to quickly go through this. So what it is second week of your semester. Again, trusses, every possible thing that we are going to go through in the rest of the semester is included in this second introduction. Again, as I told you, the whole objective of this syllabus is we are going from whole to part. So we are already telling them to design, and we are telling them what are the possible ways of looking at it, and we go through individual classes where individually we will be even discussing in detail. Yeah. So again, we are almost covering 3-4 hours class in just few minutes. It's a very good slide. I was unfortunate to get this. It's available, but I have also downloaded. So just ensure that you take the current copy of whatever is there. That's has got the right content. And I would say make it even available to students. Make it available to students if they want to learn. Let them learn on their own, things like that. So some of the questions that we could ask in this thing is available systems, how to do and things. Another 5 questions we have to be able to generate out of this. 5 to 10 questions we can easily generate out of this thing. We look at every 10 questions for each topic is what the criteria is, and others also pull in. We'll initially send out an email. We'll add more questions to that and then. Okay, when you see, this is the chart that I was talking about. This is the chart that I was talking about, which was developed by
connect ಆಗಿಲ್ಲ ಚಾರ್ಜರ್ ಕನೆಕ್ಟ್ ಆಗಿಲ್ಲ ಸರ್.
battery down is there. So this is the chart that I was talking about, which we developed. It's there in our book. Professor Gowda, he was my professor, and this is we'll go get to the details of anything. This has got what we call as a span to depth ratio and span to individual member. Span to depth ratio is one thing. This is what we call a span to depth ratio, the one ratio for each of this typical systems. We'll go in detail. Another one is member to thickness ratio. Okay, in the third week, we are going to introduce them to loads. Again, seismic load is not included. We are going to introduce seismic load in the next semester. So, when we do the thing, this semester will not. We'll only go focus on dead and live load that we have anyway taught. We don't have to. We just have to revise.
It's there.
It is there. It is there. I know, but it is. I mean, too much of content. We introduce, just introduce, but let's go into the detail. In the next semester, we go into the detail about seismic, at least the basics about it. I'll tell you why it is important is, I mean, you can just introduce, that is not a question. See, this you have introduced, the dead loads you have introduced, the dead loads, what it is, what the density, it's just basically density, Dead loads means essentially we have to get the density. పాయింట్ అనుకున్నా అది డైరెక్ట్ See this view, we are coming to the third week of semester. You know, we are talking about loads here, and again, we don't have to teach everything in that week. It can distribute it to in the second, third, or thing, no. But the whole idea is to cover these topics. That's all what it is. It need not be that you have to cover in that thing. You can probably explain these 5 systems in one and ask them to work for a period of 5 weeks. That is also fine, because it cannot be like 1 week this and things like that. It is up to the means and methods of teaching is up to the individual faculty. But the whole idea is to cover the content, and to cover the content in what you call is in the generic term, not in the thing. So when one of the questions that we are asking is trying to get the total load of the structure. So in the dead load, you know, this is where the dead load comes into the picture. So if you are using fabric, steel thing, the density comes out from here. And again the questions is what is the density of steel, what is the density of concrete. These are again questions, you know, we already asked in the previous semester. Again we can easily load 10 to 15 questions in this just by this we can use load this thing. And again live load, I think here there is no question of live load because it is a roof load. Again, you know, that's the only difference here, because we are not going to, unless that floor is going to be used for some other purpose, it is essentially the roof that we are talking about. But still they can get an idea about the loads, and you can ask questions what is, and there is something concept of reduction of live load.
Reduction will become only when there are several floors.
No, even for the larger area and the roofs also, but let's not get into those details of it. But there is a roof load that is there, and that roof load depends on the angle of inclination of the roof also. So that those ideas can be talked about there, and we generally talk about other live loads also. Yeah, that's one more thing that's here. Because snow load is a live load. Snow load is a live load, which is not there part of it. And again, the most important difference from the previous 2 semesters to this semester is the wind load. So here they will be going ahead and getting a simple calculation for how to get the wind load based on our code. And it's a simple calculation. We go through that this thing, and so essentially we'll be introducing them to wind load. Yeah. So here we are going to give them a simple calculation about how to get the wind load on structures. So essentially there is one simple formula. It's actually 2 simple formulas. This is one Vp times these 4 coefficients. They should know about these 4 coefficients. I've also enclosed the mandatory book in our thing, and we'll go over individually how to get those numbers also. Those 4 factors is, one is the design wind speed at a height z in the thing, which is about 0 to 10 meters. K1 is a probability factor. One is based on the topography. K2 is terrain roughness and height factor. Topography. One is the importance factor, which is very depends on the importance of the structure. K2 is the terrain factor. K3 is the topographical factor. K4 is actually cyclone dependent factor. We just go over individually. So K1 to K4, K1 is importance factor. So whether it's a hospital or things like that. So here the factor is not 25, it's 0.07 or 0.08 kind of thing. You know, there is a table for it. So we first get that. What was that factor?
Wind speed, wind velocity or wind speed load.
First,
we teach in roof trusses. That can be taken 0.075 minus alpha into 10 degree if it is inclined, and calculate on the nodal points.